This video will show the atomic structure differences between the three isotopes of hydrogen. I'm going to demonstrate each one of the isotopes in terms of its nuclide symbol. The nuclide symbol is represented using the element symbol. Here it's represented as X, just for example. So this is just an example of how to set up the nuclide symbol. So you would put the element symbol, capital letter, and then whatever, if it's a capital letter, lowercase letter, you'll include the lowercase, but you have your capital letter symbol. Then on the bottom left is going to be the atomic number of the isotope, and the top left corner of the symbol will be the mass number of the isotope. So what we have learned is that isotopes are going to be atoms of the same element, but they have different masses. So atoms of the same elements are going to have the same atomic number, but different mass number. So what varies is going to be the number of neutrons in the atom. So let's take a look here. Let's talk about hydrogen 1. So hydrogen 1 is how we're going to name the first isotope of hydrogen. So the isotopes of hydrogen actually have names protium, deuterium, and tritium. But in order for us to simplify our isotope naming, we are going to name all isotopes based on the element name dash mass number. Okay, so isotopes will be named by element name, mass number. So let's begin with hydrogen 1. Hydrogen 1 means that we have a hydrogen atom with a mass number of 1. So we begin by writing the symbol H. H for hydrogen, and we know that the mass number is 1. How do we determine the atomic number of an atom? The atomic number is always going to be the number that is represented on the symbol on the periodic table. So let's take a look here. I'm just going to share my screen here for a moment of our periodic table. So when we look at the symbols on each block in the periodic table, the symbol is always written in the center, and above the symbol is going to be the atomic number. Below the symbol will be the atomic mass. So we're going to need to recognize the difference between atomic mass and mass number, but that's not until later in this lesson. So for right now, we're recognizing the atomic number is found on the periodic table, the number that is above the symbol. So of course, that's a little bit contradictory from what we have on the nuclide symbol. The nuclide symbol writes the atomic number in the bottom left corner of the symbol. Okay, so we must remember the difference. Okay, we find the atomic number on the periodic table on the top, but when we write a nuclide symbol, we write the atomic number on the bottom left corner, mass number on the top left corner. So what does the atomic number tell us about the atom? The atomic number tells us the number of protons in the atom. Okay, so let's write out the description of what's within the hydrogen 1 isotope. We will have 1 proton. I write it as P plus in order to represent the positive charge on the proton. We have 1 proton in the atom of our hydrogen 1 isotope. Now, if we want to know the number of electrons, and we know that this is a neutral atom always has the number of protons and electrons equal to each other, because the positive and the negative charges will then be cancel each other out to make the total atom neutral. So the number of protons tell us the number of electrons in the atom. Okay, you're going to be learning about ions. So it's going to change slightly. It won't always be that the number of protons equals to the number of electrons, but in a neutral atom, protons are equal to the number of electrons. Now, what else is in the atom? We have neutrons. Neutrons are going to be found in the nucleus with the protons. It makes up the bulk of the mass, is the nucleus. So the mass number will be equal to the number of protons plus the number of neutrons. Okay, well, we know the mass number is 1. We know that we have 1 proton. Therefore, we must have 0 neutrons in the atom. Okay, and then let's just remind ourselves that the atomic number is equal to 1 and the mass number is also equal to 1. So just from the nuclide symbol, we are able to determine all the parts of the atom of a hydrogen isotope. So we can do the same thing for hydrogen 2 and 3. For hydrogen 2, the difference will be that now the mass number is 2. So if the mass number is now 2, what has changed in the atom is the number of neutrons. So we still have 1 proton, 1 electron, but now the difference is going to be that this atom will have 1 neutron. Now this isotope is going to have the same atomic number. The atomic number defines the element. When you change the atomic number, it's no longer the same element. So the atomic number for hydrogen is 1. The mass number for this particular isotope of hydrogen is 2. So the name is hydrogen-2. Now for the third isotope, we have hydrogen-3. What that means is that the mass number is 3. So we have hydrogen, the atomic number stays the same. Mass number is 3. So now what this means is we have 1 proton, 1 electron still, 2 neutrons now. Okay, so how do we figure out the number of neutrons? We can subtract the mass number from the number of protons. So subtracting 3 minus 1 gives us our 2 neutrons. And then just as a reminder, the atomic number again, mass number equals 3. So this you will apply to all isotopes.